Hi friends, Miss Cedarquist here. Welcome to the last page of notes for this distance learning section of our class. This page of notes is going to go on page 25 in your interactive notebook, if you've got one. And our learning objective is to graph quadratic functions using the axis of symmetry, the vertex, and a symmetric point. Our language acquisition objective is to explain how to graph quadratic functions using academic vocabulary in today's focus notes. And your essential question is, how can I graph a quadratic function to help us solve quadratic equations? So before we get into examples, let's just talk about what a quadratic function even looks like when it's on a graph. So y equals ax squared plus bx plus c. This is what you've seen for the last week. This is not new, but the y equals part is new. Now, when we graph that, it produces something called a parabola. And a parabola is a symmetric shape, meaning that if I were to fold it in half, what I have on one side is the same as what I would have on the other. So that fold line where I would fold it in half is called the axis of symmetry. And that highest or lowest point, so in this case, the one that we're looking at is actually the lowest point on the graph, is called the vertex. All right. Then, let's just talk about what a parent function is. So the parent function is the most basic quadratic function that we've got. So the graph of a quadratic function is y equals x squared, meaning it has nothing extra with it. So this is the table of y equals x squared. If I plug -1 in for x squared, I get -1 squared, which equals +1. If I plug 0 in for x, I get 0 squared, which equals 0. And if I plug 1 in for x, I get 1 squared, which equals 1. So this is the same every single time for the parent function. Now let's just graph these points. If I plug -1, 1, here's -1, here's +1, -1 and 1 is right there. And how about 0, 0, that's right here. And then 1, 1, here's +1, there we go. And connect those dots. We don't want to make harsh arrows, like you don't want a V, you want a U shape. So this is the parent function. Now everything after this parent function are just shifts. So we could be shifting up, we could be shifting right, we could be shifting left, we could be getting a skinnier U, we could be getting a wider U shape. All of those depend on all of these extra A, B's, and C terms. So let's just talk about those shifts real quick before I start graphing. First thing, if A is positive, we call this a happy face parabola because it opens up. So if A is a positive number, it opens up like this. Now, if A is negative, then the parabola opens down and it's unhappy. If A is bigger than 1, then the parabola is thinner than the parent graph, meaning it's vertically stretched by a factor of A. But if the parabola is a fraction, like it's smaller than 1 but bigger than 0, then it's wider than the parent function, meaning it's like just vertically shrinked, it's just up. And then C, if the C is positive, then the parabola is going to shift up. And if the C is negative, then the parabola is going to shift down. So let's talk about what all that means in our first example.